Hello ladies and gentlemen, it's time to do some slant asymptotes, which we're going to use some long division, and then we get to draw them. The nice thing about slant asymptotes is they're usually pretty predictable to draw. Once you get the asymptotes drawn, then you don't have a whole lot of choice as far as where things go, so you don't have to do as much testing of points like when we did the other ones. But the main idea here is when you have a higher degree in the numerator, then there's not going to be a horizontal asymptote. Instead of having a horizontal asymptote, well, what we're going to do is we're going to have a slant asymptote. And the way we find the slant asymptote is by using polynomial long division. So say polynomial division. So we've done the case where the numerator and denominator have the same degree, and all the other problems have been the denominator, the bottom of the fraction, is a higher degree. Now we're going to do problems where the numerator is a higher degree, and so we're not going to have a horizontal asymptote, we're going to have a slant asymptote, and like it says, we're going to use long division to find the equation of the slant asymptote. So first thing, let's do what we've been doing and analyze what we can. So we can still find the x-intercept. We're going to set the numerator equal to 0. When you factor that, you get x minus 5, x plus 1. So that means there's x-intercepts at 5 and negative 1. Those are the zeros of the numerator. The y-intercept, if you plug in 0 for x, you get negative 5 over negative 3. So that's positive 5/3. And the vertical asymptote will still be when the denominator is 0. So x minus 3 equals 0 at 3. So let's draw what we have. 1, 2, 3. There's my vertical asymptote. And my x-intercepts are at 5, 0 and negative 1, 0. And my y-intercept is at 0, 5/3, so that's right about there. Now what I don't know is the slant asymptote. So the way I'm going to find that is I'm going to use polynomial long division. So I'm going to have x minus 3 as my divisor, and x squared minus 4x minus 5 is my dividend. So a little refresher here with long division. The goal is to repeatedly eliminate this first term. And to do that, we're going to figure out what we multiply x by to get the first term. You can also think of it as division. So x times x gives you x squared, but you have to distribute the x, so it's x squared and then minus 3x. So once you distribute your x into the dividend, you get this. And now remember, when you do long division, you're going to subtract. So this becomes minus, that becomes plus, and those will cancel. And we just repeat this process until we have a remainder that is a lower degree than our divisor. So let's see, negative 4 and positive 3 make negative 1x. Now I do it again. So x times what gives you negative x? That would be negative 1. Now I will distribute a negative 1. So it's negative 1x plus 3. Negative 1 times negative 3 is positive 3. Then you flip the signs, so plus, minus. Those will cancel again every time. And you get negative 8. So my remainder is negative 8, which when we're doing the long division problems for slant asymptotes, the remainder actually isn't really, we don't really care about it. What we care about is this. This quotient, x minus 1, this is the equation of our slant asymptote. So what I'm going to do is draw the equation, or graph the line, y equals x minus 1. So y equals x minus 1. To graph a line, you start at the y-intercept, negative 1, and then you count the slope, up 1 over 1, up 1 over 1. So up 1, up 1, up 1. And I'm going to do that a bunch of times because I want to have as many dots as I can to draw a nice straight edge. So this is going to be my equation of my slant asymptote. There you go. And I'll make it a dashed line so we understand it's asymptote, it's not part of the function. Okay? So now, what I was saying before is, usually when you get to these slant asymptotes, you kind of have only one way to draw it. And this is one of those cases where we know the end behavior, we know it's eventually going to follow these asymptotes, and since we're kind of already on one side of it, the only way I can draw this without crossing the vertical asymptote is by going up and then following the asymptote. And then naturally that's going to lead us to follow along the slant asymptote. Similarly, I know I can't pass this vertical asymptote, so then I'm pretty much only left with going up this way. So now I have the graph of my function. I drew my vertical asymptote, my slant asymptote, and now I have the actual function. So that's it. You do long division to get the equation of that slant, and then usually you can sketch it pretty easily. Let's try another one. So we're going to first do the same thing we did on the other page. So I'm going to steal this so I don't have to keep typing. Copy and paste. There we go. X-intercept. We'll factor the denominator, x minus 2, x plus 1. And then the denominator we have 1 minus x. So when does the numerator equal 0? That's at 2 and negative 1. Those are the zeros of the numerator. The y-intercept, if you plug in 0, let's see, what do you get? Negative 2 divided by positive 1 is negative 2. And then my last thing, my vertical asymptote, the vertical asymptote, 1 minus 1 is 0, so the asymptote is at 1. Let's draw what we have so far. Vertical asymptote at 1. X-intercepts at 2, 0 and negative 1, 0. Actually, I'm going to do those in different color. 2, 0. Those are actually the function. Negative 1, 0. Y-intercept is at negative 2. Okay. And we got the vertical, we got the intercepts. All right, now what I need to do is find the slant asymptote. So I'm going to write this in standard form for my divide. Negative x plus 1. And then, I don't like it. So you want to use in standard form, so I'm going to rewrite the order there. X squared minus x minus 2. Now, what am I going to multiply negative x by to get positive x squared? That would be negative x. Negative x times negative x is positive x squared, and 1 times negative x is negative x. Now I will flip these to be their opposites, and look at that. These x's also cancel out, so you get 0, and then the remainder is negative 2, but again, I don't care about the remainder. The remainder doesn't affect the quotient, which is what we're looking for here. This is our slant asymptote, so y equals negative x. That is a line that passes through the origin with a slope of negative 1. Looks like, oh, I nailed it, perfect. Looks like that. Slope is negative 1, the y-intercept is the origin, 0, 0. This is another one where it's pretty easy to draw, because you have to follow these asymptotes. You gotta go up. You can't cross that vertical asymptote, so you gotta go up that way. And then you got to go down this way along the slant asymptote, because you know the end behavior is going to follow that slant. Same thing here. You can't pass the vertical asymptote, and then we're going to follow along the slant asymptote. And that's going to get closer and closer. The more you zoom out, the more obvious this will look like an actual line, y equals x. If you were to zoom this out in Desmos quite a bit, it would look like you have drawn a line. But we can see there's actually that vertical asymptote there that you have to pick up and that's getting passed. Let's do one more. So first thing, I'm going to make sure I have my little template there. When I factor the numerator, I get x plus 1, x plus 1, and that's over x minus 2. If you're having trouble factoring polynomials with 1x squared, then you are in very much trouble, and you are not ready ever. Do not take calculus. Like, that is a major red flag. So that I'm leaving for you to do. X-intercepts are when the numerator equals 0. That would be at negative 1. So we only have one x-intercept. Okay, it's a multiplicity. That way. Y-intercept, 0, let's see, 0, 0, 0. 1, negative 2 is negative 1/2. Vertical asymptote is when the denominator equals 0, that's at 2, so let's draw what we have. We'll plot my intercept at negative 1, my y-intercept at negative 1/2, my vertical asymptote at 2, and I'll do that in yellow again, 2. Go. Now we will do long division to find our slant asymptote, because the numerator is a higher degree. So it's x squared plus 2x plus 1. So x times what gives you x squared? That would be x. Now distribute x squared minus 2x. X squared minus 2x. And now we will flip our signs. So minus plus cancel. And 2 plus 2 is 4x. Be careful, those don't cancel. 4x plus 1. We do it again. X times what gives you 4x? X times 4. Distribute. 4x minus 8. Flip your signs. Minus plus cancel. And you get a remainder of 9. But again, I don't really care about the remainder. I care about this, my quotient. Y equals x plus 4. That is the equation of my slant asymptote. So I will start at the y-intercept 4. 4, and I will count my slope, which is 1, so up 1 over 1, and I will draw a bunch of dots to help me draw this slant asymptote accurately. And I get something like that. Pretty good. And I can see that I know I'm going to go down like this, and then I think I have to go up like this, but in this one I am going to have to test some kind of point. So, because I don't know if it's up here or it's here. It could be either one. So what we'll do is we'll test a point that we think might work. Let's try 3 and see what happens. If I plug in 3, what do I get? If I plug in 3 in the top, I get 3 plus 1 is 4. So 4 squared over 1 is 16. So 3 is at 16. Well, that's pretty far up there. Wait. Yeah, that doesn't really work, does it? So that's pretty far up there. I think that means it has to be up here in this section. So I'm going to draw it knowing that it's not going to be perfect, but I can't really fit it on this page because it's off the page. So it's going to just kind of be the best thing I can do. I know where it is, I just can't really fit it on this grid that only goes up to 9. So it actually would be 3, like 16's up here somewhere. So it's going to do that just a little bit off the page. So what I really care about is, sort of like what, not really a quadrant, but what section of the, how the asymptotes are separated. So that's what you need to be able to do for slant asymptotes. So make sure you go through and check your math labs, and you still have that Desmos assignment. If you didn't, watch my other video to make sure you know how to do that. Watch my other video, get your Desmos assignment done, get your math lab done, and while you're at it, hit that like and subscribe button.